Welcome to all wonderful learners. Today I am here to discuss a very important topic from acid, bases and salts. What are our learning outcomes? How to dilute an acid. And thought of the day, you are unstoppable. Let us move how to dilute acid. Yes, this is a very important question. How to dilute acid and the way we are following. Why? Yes. So dear friends, let us first go towards normal life situations. How we dilute anything. Dilute means anything. For example, milk. If you want to dilute milk, we will add the solvent. Solvent is their water, right? So I will add water, right? Let us take an example. I am having KMnO4, potassium permanganate solution, right? It is an aqueous solution. KMnO4 crystal I have dissolved in it, and I am having water, the solvent. So how to dilute? Very simple. I will add this solute, solvent, water in the KMnO4 and it get diluted. This is our normal life situations. We are doing this, right? But is the same trend is followed by the acid dilution, or it is different? It will be different than what? Let us see what happens. In the first case that is given here, that water in acid. That is the general way. I will add water, right? I am having water here and there is acid. Now we have to assume, we have to think about the things, the situation. Now acid and water, first thing we should remember, the reaction between acid and water, it is an exothermic reaction. We know exothermic reactions are those where large amount of heat is evolved, right? When heat is evolved out, now, right, what will happen? It will increase the temperature of the container. If the reaction is exothermic, when I will add water in acid or acid in water, both way, because acid and water, they are combining. One is acid is an acid and it is just like a base. You know, reaction is just like neutralization, and reaction is an exothermic. Heat is generated. That heat will increase the temperature of the container where they mix up, and more temperature can blast the container. Water liquid present here that can explode out. It will come out, right? Splash out, and it can spoil the part where it formed, right? So now see the first situation. If I will add water in acid, this first one, this is your acid, this is your water. I will add water in acid. Now reaction is very exothermic. It's very exothermic reaction, right? Temperature increases, and if more temperature increases, now see, it will, for example, get blasted, right? Liquid splash out, and here it is, acid is more, right? Acid is more. It splash out. It will spoil all the parts of the person doing experiment, performing, working in lab. So due to this reason, it is more dangerous, right? We never add water in acid. Case 1 is never followed by a scientist, right? By a student, by a person working in the lab, because reaction is exothermic and the liquid present in the container will splash out due to the high temperature, and it is more dangerous, right? First situation is wrong totally. Let us see second way out. I am now adding in another way. I will mix acid in water. Acid is more dangerous. Water having no any effect. It is a neutral. We are eating, we are drinking it, we are taking bath. It is not harmful. Harmful is acid. It is corrosive in nature. Alright? See, when I will add acid in water, right? Okay, reaction is actually it's having temperature higher temperature. But now if splashing out of the liquid due to high temperature is there, then what will happen? Water is more. It will come out if it will not cause harm, right? It's not hazardous for us. The case one is very dangerous. So this is the reason why we always prefer for dilution of an acid to add acid in water. We always add acid in water. So always add acid in water, right? So this is the reason that why always due to dilution, this way of dilution we will follow. Always add acid in water, right? So the thing is clear? Alright. And at last, this you are unstoppable. Definitely, we are unstoppable. Thing is that we should just think on, right? Our potential. We are having huge potential hidden inside. We have to activate it. For that, we have to take steps. We should initiate it, right? Initiation is required. As ignition temperature is required to have the burning reaction, have combustion, same here. And then the reaction goes automatically, spontaneously. So please know your hidden potential and move ahead. Never give up. Because this is our nature to be unstoppable. Because we are energy and energy always flows. That's it for today. Thank you very much.